One of the world's most celebrated and forward-thinking physicists today, Michio Kaku, recently shared his opinion on a revolutionary discovery. Famous for his pioneering research in the science of physics, Kaku confirmed that the James Webb Space Telescope has found 6 giant galaxies that, according to current scientific understanding, shouldn't exist. This discovery may redefine our concept of the universe and holds great prospects. Something to keep watching. Michio Kaku is an American-born Japanese-American physicist of Japanese origin. He's world-famous in the scientific community as a specialist in classical experimental physics as well as quantum mechanics. While some of his more skeptical and conservative colleagues have greeted this with suspicion, Kaku has embraced the shocking discoveries of the James Webb Space Telescope. By being willing to talk about this discovery publicly, he has generated interest and debate. Speaking about it, he was genuinely excited, calling this moment one of the highlights of his scientific career. Throughout his career, Kaku has been open to new ideas and hypotheses. He acknowledges that Newton's laws and Einstein's relativity, though basic, are not enough to explain the complexity of the universe. He believes that the James Webb Space Telescope findings have the power to revolutionize the sector, though a majority of his colleagues are yet to accept these findings. The implications are so vast that they're creating excitement as well as fear, especially among the staunchly Big Bang Theory-bound and skeptical of quantum mechanics. Kaku, however, takes it all in stride, often answering with humor. The telescope discovery of 6 titanic galaxies dating back to the earliest times in the universe has left scientists stunned. Each of them contains more stars than the Milky Way, but they formed only 200 to 700 million years after the Big Bang. The discoverers have referred to them as universe breakers because, if proven true, they deny nearly everything we know about cosmic evolution. This finding is serious. The Big Bang theory holds that the universe began as a hot, random state. Hundreds of thousands of years went by before the first atoms formed and far longer before matter came together in galaxies and stars. But some of these newly discovered galaxies are as big as the Milky Way and extremely bright, meaning that they were creating hundreds of stars each year, many more than our galaxy. Up to now, scientists have been unable to determine when the first galaxies emerged. The common idea is that during the early period of the universe there were either isolated stars or small groups of stars that coalesced eventually into dwarf galaxies. The dwarfs would hit each other and grow. The presence of such massive and beautifully formed galaxies so early in the history of the universe causes scientists to question whether the universe might be older than previously believed, or whether complex things emerged much sooner than they considered. It's an idea difficult for ancient science to swallow. Certain physicists strongly object to it and questioned whether there was an error made in the measurement of galaxies' ages. Kaku had expected this response and countered it head-on, pointing out that most old theories still linger due to the power behind them. He reminded us that science advances through experimentation, and it is the experimentalists who keep theorists in check. He stressed that our knowledge of the origins of the cosmos is still very limited. The Big Bang theory, introduced as early as 1927, was the result of the observation of the universe expanding. It proposed that all began from a single point and has been expanding since then. This idea was hard for humans to accept at that time. An eternally, infinitely large universe had already been the prevailing opinion. Even now, most scientists find it challenging to accept a universe that had a start and could potentially have an end. But with these new discoveries, long-standing assumptions based on the Big Bang model are being challenged. Science, however, has always evolved by questioning accepted ideas and embracing new evidence. Confirming theories is important, but so is remaining open to the possibility that we've missed something. When Einstein was a kid, everyone believed that planets and stars were fixed in the sky. Now we know the universe is constantly on the move. Planets orbit stars, stars travel through galaxies, and galaxies travel through space at mind-boggling speeds. Much of this motion still can't be precisely forecast. Modern scientists face the task of accepting unpleasant truths. Theories are not facts. They're models that must be tested rigorously. The Big Bang theory was, in part, based on the fact that galaxies are receding from one another, a pattern known as Hubble's law. Additional evidence came from cosmic background radiation and the redshift of light. However, it should be remembered that even popular ideas were once proven wrong again when more advanced equipment and new data became available. We are now in the same sort of situation. Scientists had been expecting the James Webb Space Telescope to confirm existing Big Bang presumptions, but it brought to light something that appears to contradict them. It is a powerful reminder that science is dynamic and evolving all the time. Theories must evolve to accommodate new discoveries. One of the primary weapons used in this sphere is redshift, a phenomenon very much akin to the Doppler effect. When a source of light is moving relative to an observer, the light's wavelength is altered. When an object is coming towards us, the light turns blue. When it is moving away from us, the light turns red. Scientists take this redshift and use it to determine the speed and distance of celestial bodies. However, even slight inaccuracies in these measurements can have drastic consequences, so new techniques are closely examined. With the most recent findings from the telescope, scientists are now compelled to wonder whether the findings are the product of redshift calculation mistakes, or whether the evidence simply will not fit long-established dogma. This calls for meticulous examination and deep analysis of the data and methodology involved. Thank you very much for watching the video. As always, we invite you to leave your comments. If you enjoyed the video, don't forget to like it, share it with others, and subscribe to the channel so you won't miss the next content. Thanks again for watching, and see you next time. However, it is important to consider these probabilities. Once again, these new demonstrations do not fit at all with what researchers have based for decades on the Big Bang theory. However, science has shown time and time again that revaluation and openness to new ideas are an integral part of the scientific process, as is the confirmation of certain theories and observation. When Einstein was growing up, we thought that stars and planets were rigidly embedded in the universe and these specific formations took up a set amount of space. But now we know that the whole universe is in motion. Planets orbit around stars, stars travel at hundreds of kilometers per second in their galaxies, and galaxies race through the universe, the destiny of which we are not yet even able to determine. Today, scientists are forced to accept uncomfortable truths and realize that theories are not speculation and are not the truth until they are fully tested or established by accurate observation. The Big Bang theory was developed as a result of observing that galaxies are moving away from each other, and the farther away they are from Earth, the farther apart they are. This observation, known as Hubble's law, gave rise to the idea of the universe expanding. For many years, cosmic background radiation and the redshift of light from distant galaxies and other cosmological structures provided support for this theory. Still, one can't forget that in the past, persons who thought that the Earth was flat and that the Sun revolved around us had this converging evidence to support their assumptions, until coincidence or technological improvements came along that provided a clearer and more accurate picture. We are seeing the same today. Scientists wanted the new JW Space Telescope to confirm the theories about the Big Bang, but they have instead discovered these 6 impossible galaxies. It is a reminder that science is constantly evolving, and that scientists must be open to the new discoveries and reassess present theory based on the facts. Scientists employed redshift as a means to calculate some of the values they were trying to obtain in their cosmology research. Redshift is also referred to as